Alright, got your spare battery there. Here's the main one. Crank it up.
Hit the gas! Hey everyone, I've got a quick video about how I converted my daughter's 12-volt Jeep to run on Milwaukee M18 batteries. Now there are a lot of videos out there about Power Wheels to power tool battery conversions. This one I did a little bit differently because I actually used a step-down transformer to take it from 18 volts to a little bit lower voltage because there was some electronics in the vehicle that I didn't want to mess up. So the first thing I did with this Jeep is I took the battery and the main plug for the electronics, and I cut off the ends and replaced the connectors because I couldn't find compatible connectors. I also did that with the stock charger that trickle charges this lead acid battery. I just made sure I kept the right polarity, and there you have it. It still works. This is the original configuration just with new connectors on it. So this way I can either plug in the main battery or I can plug in the buck converter, and it's basically a stock Jeep how it is, or I can use my M18 batteries. I got the M18 battery, plug it in here. The fan starts going automatically. So instead of running the car at 18 volts, which is 50% over its design voltage, I wanted to run it at slightly higher and just have an M18 battery so I didn't have to wait 8 hours for the lead acid batteries to charge. So my plan was step it down to something a little bit less using a buck converter. This just takes DC to DC, takes a higher voltage, steps it down to a lower voltage. This one is rated for 200 watts, and you've got to pay attention to wattage. I used this one to start with, and everything went great. It worked fine. When she tried to climb hills, it stalled out. I watched the voltage drop down to nothing, and the car would actually restart. It was starving current to the car itself. It was the motors were trying to draw too much power, and this couldn't supply it. So I moved up to a 300 watt buck converter. You can see the heat sinks on this are about 50% bigger. Neither of these has active cooling, but I wired up a fan to do active cooling, so that keeps it from overheating, and that keeps it able to supply that power throughput that I need. Now the one thing you do have to pay attention to this 300 watt board is right here you've got a voltage and current. So you see the CC, that is for constant current, and over here is constant voltage. I adjusted this one with a multimeter until it said 14 volts and left it there. And then I cranked the current one all the way up because I didn't want to be limiting current. I wanted to be able to output as much as the motors needed. So I turned this one all the way clockwise and then let it sit. So I ended up 3D printing an enclosure for this because this is just a board and you don't want it rattling around. And I'll put the file in the video description below. You can download it if you want and do the same thing if you have access to a 3D printer. I started with one that was sized for the 200 watt converter, and then I bumped it up a little bit higher for the extra height of these heat sinks, and the 300 watt, they had pretty much the same footprint, which was nice. And I also sized it for these fans, this standard computer fan size. You can just run screws straight through that into the top, and it makes the lid for the whole thing. And then I wired that fan into our battery takeoff, so that's getting 18 volts, and our output is right here. I also just bought a cheap 18 volt battery converter adapter for my M18 batteries. It works great. You just wire it straight into the buck converter. Now I did tap the plastic on these, so it goes in and the screws actually bite into the plastic. I think it's an 8x32 I did for these top ones, and then the inside ones, the board mounts on, are 4x40. You might just want to do through bolts on those and make the holes a little bit bigger in my files, but it worked for me. It was just a little bit messy because the plastic would gunk up these taps. So the lead acid battery that's in my daughter's car originally was open circuit voltage of 13 volts. These are open circuit voltage of 20 volts. So I'm stepping this down to 14. And the only voltage drop I see when she's going up really steep hills is down to 13.75. So this actually does a better job than the lead acid battery. I'd see that drop a whole volt or more when she was going up hills. So this does a better job of supplying power to those motors when they really need it. Now the connections I used for this, I used a heat shrink gun and these heat shrink connectors. These things make it a whole lot easier. They actually have a solder bead inside them and then some epoxy on either side that seal against water and then it solders the two joints together, the two wires together. So it's an all-in-one. You just stick them together, put this on top, and heat shrink it closed. It's really simple. You just have to make sure that bead actually melts in the middle. And to do that with the M18 cordless gun, you really need this shield on it. It helps for any heat gun that you're using to have one of these shields, but that helps it melt a lot faster. Now, word of warning, one thing I didn't account for is a low voltage cutoff. I haven't drained a 5 amp hour battery yet. If your kid's gonna drive 5 miles on it, they might drain one of these. And I think this has protections in the battery, but I don't know if it relies on a Milwaukee M18 tool to do the hey, we're done, we're not outputting any more current, or if it's completely in the battery. If it's completely in the battery, you're good. Otherwise, you might wanna think about getting in between here a little board that does low voltage cutoff, and you can set that. Just drain one of these batteries using an M18 tool, check the voltage on the battery, and then use that to set your low voltage cutoff. I didn't bother with that because I mean, we've never emptied one of these before. I just keep an eye on it. You don't want to leave these plugged in because this will continue draining with the buck converter because it uses a little bit of energy to do that. Just know, if you're worried about that, you might want to put a low voltage cutout in here. I just didn't want to have another bottleneck in the current going to the car, and I wanted to make it simple and keep that just the buck converter that might be my source of bottleneck, and that seems to have worked really well. So let's talk actual results and performance gains I've gotten from converting to the 18-volt batteries. It originally was rated for 3.7 miles per hour for her Jeep. It's now going 5.5 to 6 miles an hour on the flat. On downhill, I've paced her at 9 miles an hour. It's getting a little sketchy at that point, so I'm glad I didn't crank this all the way up to 18 volts. Range on this with these 18-volt batteries is absolutely fantastic. With a 5 amp hour battery, it's getting about 2.5 miles on a half charge. So that's like a mile per amp hour we're getting out of these things, and I can fit 3 of these in there with the original battery. So I think I've got somewhere around like 17 miles of range with 3 5 amp hour batteries and the original battery. If I took the original battery out, which it's still compatible with, by the way, I just swapped connectors, we're actually looking at maybe 20 miles or more range. Over the life of this little car, I think we've gone at least 70 miles on it already. We might be getting close to 100. Unfortunately, I haven't kept track. The next thing I'm going to have to address is actually getting something to fix the wheel treads because they're starting to wear off completely.
No way! Keep going! Keep going! You can do it! I'm right behind you to catch you. This is the ultimate hill crawler. Oh my goodness, the tires are slipping. I think it's got power. All right, go. I'll push you a little bit. They're spinning the wheels on this thing. I think if you had traction, you could have done that.
So anyway, I had some awesome success converting my daughter's car to an 18-volt battery. I'll put a link to all the parts I used below. I had a lot of these lying around already. It does kind of add up if you buy them all at once, but you might be able to cobble together some, random odds and ends of electronics that you already have. The only things you really need for this are the buck converter, which is $20 for 2 of these, and then an adapter. I think this one was $5 or $7 or something like that. And I had these fans lying around. They're only a few dollars each. You can probably cobble together the rest with random stuff. If you have a 3D printer, you can do this. If you don't, you can probably make it out of wood. Just make sure you have enough ventilation in it.
Keep going. You just got to hit it. All right, let's go.